11.3, probability of multiple events. So this is when we're dealing with a probability of an and or. So if I say, what is the probability of rolling a 5 and 3 when having a die? Or if I have the probability of rolling a 5 or 3. Well, I have a die, I can't roll a 5 and 3, so that's impossible. But with the or, I have 2 different options out of 6. So those are just 2 examples of an and an or. First, independent and dependent events. Independent. When you think of the word independent, you should be thinking of someone who likes to do things by themselves. Or the Beyonce song, All the Women Independent. Throw your hands up at me. Because women who are independent don't need a man in their life. So independent means one does not affect the other. Dependent means one does affect the other. So I can't have one without it changing the outcome of the other. So are these independent or dependent? If I roll a number cube and then spin a spinner, do those 2 things affect each other? No, they don't. So this would be independent. They don't affect each other. Pick one flashcard, then another from a stack of 30 cards. So do those affect each other? Here's the key with these type of problems. If I pick the card and I take it out and I do not replace it, then that's going to change my total. Remember, when we're dealing with probability, total is always on the bottom of the fraction. So these would be dependent because it does affect the other. When I have a probability and I have an and statement, they're independent. The one does not affect each other. I'm always going to multiply the 2 probabilities that I have. So for the first one, at a picnic there are 10 diet drinks and 15 regular drinks. There are also 8 bags of fat-free chips and 12 bags of regular chips. If you grab a drink and a bag of chips without looking, what is the probability that you get a diet drink and a fat-free chip? So first I'm just going to look at my diet drink. First, I have 15 total. So I'm going to put 15 on the bottom here. And 10 of those are diet. So that's my first probability because the drinks do not affect the chips. And then I look at my chips. I have 8 fat-free and 12 regular, so that's going to be a total of 20. And if I want to figure out how many are what's the probability of getting fat-free, I have 8 on top. So now I'd multiply those 2 together. And you would get that this would be 0.2666. So I'm going to say this is 27% chance that you would get a diet fat-free chip. Right now I want you to pause the video and solve the second problem by yourself. You should have gotten that you got a 20% chance of getting a regular drink and a regular chip. Now I'm dealing with mutually exclusive. What does that mean? Mutually exclusive means that the probability is equal to 0, which means it cannot happen. So if you roll, the probability of rolling a 2 and a 3. Well, if you think of it, if I only have one die, I can't roll both at the same time. So yes, these 2 would be mutually exclusive because they can't happen at the same time. Rolling an even number and a multiple of 3. We'll have to think, are there any even numbers that are a multiple of 3? Yes, there is. So no, this is not mutually exclusive because a 6 is both even and a multiple of 3. So right now I want you to pause the video and see if you can do A and B by yourself. Remember, this is asking, is the probability 0? That's mutually exclusive. So A would be no, it's not mutually exclusive because if I roll a 2, that's both even and prime. B would be yes, it's mutually exclusive because there is no even number that is less than 2 because the probability would be 0. Now the probability if I have an or statement with an or. Now if they're mutually exclusive, I have to make sure, or I can just add the 2 probabilities together if they do not affect the other. But if they do affect the other, I have to subtract what repeated. So if I look at this problem, at your high school, a student can take 1 foreign language each term. 37 students take Spanish, 15 students take French. What is the probability a student chosen as at random is Spanish or French? Well, first I have to think, are there any repeated? Did it say in this passage anything about students who take Spanish and French? No. So this would be a mutually exclusive event. So I can just add 37% plus 15%. And I get 52%. That's the probability of a person chosen at random is taking Spanish or French. I want you to pause the video and try A by yourself. You should have gotten 61% because I'm adding 9% to my previous problem because there's no overlap of students here taking both Spanish and French. But what if I do have an overlap? So let's say, look here, suppose you reach into a dish and you select a token at random. Here's my dish right here. What's the probability it is round or green? So first I'm going to find the probability it's round, and I'm going to add that to the probability that it's green. Now these are not mutually exclusive. There's some that overlap. So I'm going to have to subtract the probability of having it both be round and green. So if I look at my dish here, the probability that we have round is 1, 2, 3, 4, 5. So I have 5 round, and there's a total of 1, 2, 3, 4, 5, 6, 7, 8, 9 different tokens. I'm going to add that to the probability that we have green. Here I have 1, 2, 3 out of 9 green. Now I'm going to subtract the round green ones. So here's a round green and here's a round green because I already counted that for both of the dishes. So I have to subtract 2/9. So I can have 5 plus 3 minus 2, or else you could do this all into your calculator, and I would get 6/9 or 2/3. Yes, I know what you're thinking. Can't we just count them up? Sure, but not always do I have a problem that is given a picture and it is as easy as this. Right now I want you to pause the video and try the next two by yourself. And you should have gotten 5/9 for both problems. Make sure that you filled out, make sure you did very good at writing out your notes, and have a great day.